Hello everyone, welcome to my channel. In this video we are going to understand in brief about what is an array and what are the different types of arrays and how to calculate the address of the array in both the one-dimensional and two-dimensional arrays. So first of all, let us know what is an array. An array is a finite, ordered and collection of homogeneous data elements. Okay, so here the name finite, that means a array will, so the array length is already defined, right? Suppose, so in the given array the length is 7, right? So that is a of 7, that means we are having the 7 memory allocations here. So here if you want to declare and store some elements in the array, then we have to mention the size of the array. So that means it is finite only, it is not infinite. Okay, so the number of memory locations needed must be defined here, and it is an ordered collection. So ordered means, so the array elements will be stored in a sequential manner. Okay, so 10 element, the first element is stored in the array subscript 0 and the next element is stored in the array location 1 and 30 is stored in 2. That means all the data will be in a sequential or in the ordered format. Okay, an array is a collection of homogeneous data elements, so we can store only same type of data elements in the array. Okay, so here I am storing the data elements of the integer type. Okay, or you can store elements of float type, that means only of the float values you can store in the array, or you can store only character values in the array, right? So that means we can store only one type of data in the array. So now let us see what are the different types of arrays. So the elements in an array are referred either by a single subscript or, so there are two types of arrays, that is one referred by single subscript or by two or more subscripts. In the case of the one-dimensional array, we are going to represent an array with a single subscript, that is a of I, right? And in the case of the multi-dimensional array, I am going to represent the particular array with the two or more subscripts. So two-dimensional arrays also comes under the multi-dimensional array, that means more than one dimension. So I and j, that means I number of rows and j number of columns. And here in a single dimensional array, it will represent the particular memory location in the array. Okay, so the I starts from 0 to the n number of values. So these are the two types of arrays you can know. So now let us see what is the one-dimensional array. A linear or one-dimensional array is a structured collection of elements, often called array elements. So one-dimensional array is also called as a linear array. So it consists of the collection of elements arranged in a sequential manner. So it can be accessed individually by specifying the particular location of the element by a index value. Okay, so here given the syntax of the one-dimensional array, that is data type followed by the array name and index value. Okay, so in this format we can access the particular index value. Okay, so int a of 10. So by this we are going to declare the 10 positions or 10 elements in the array. Then we can insert the elements into the array using the for loop, right? That we have discussed already. So here we are going to know only about how to know the location of or address of the particular element. Okay, so int a of 10. So suppose I want to access the location a of 4. Okay, so then it will go to the fourth position. So here in the fourth location the value is 50 and address is 1005. Okay, so these are some examples of the one-dimensional array. Okay, The street lines are arranged in a sequential manner besides the road. Similarly, the trees are arranged on sides of the roads in the sequential manner, like in the one-dimensional array. So one after the other, so the trees are arranged here, and similarly here the street lights are also arranged in a sequential manner. So these are some examples, real-time examples of the one-dimensional arrays. So next we will see how to calculate the address of a location in the one-dimensional array. So here I am considering the array with the seven locations. That is, the elements are 10 to 70. Okay. So here we are taking the array with the 7 locations, and elements are 10, 20, 30, 40 and so on 70. Since this is the integer format, so the number of bytes taken here is 4 bytes for each element. Okay. So for 10, it is starting from the base address, that is 1000 and 1004. Since each element is having it will occupy 4 bytes, so we are leaving the 4 bytes for the each element, and then 1004, 8, 12, 16 and so on 24. Okay, so here each element occupies 4 bytes of address location, and the base address is 1000. Okay, suppose you want to access if you want to calculate the address of a particular location, then A of I equals to B plus W into I. So here B is the base address, W is the size of the particular element, and I is the index value or subscript value. Okay, so where we want to find that particular subscript value is given here. Okay, so now we will see how to calculate the address of location in the next example. So int A of 7, so these values are there in the array, and here I want to know the element, that is 60. Okay, I want to know the address of the A of 5. Okay, so here I want to know the address location of the A of 5. So A of 5 equals to, what is the base address here? 1000, right? So the array starts from the address location 1000. Okay, so whenever an array is created, a pointer will be created to the array storing the address, that is the base address of the array, right? So whenever we want to access the particular array, so based on the base address only we will calculate the address of a particular location. So 1000 plus 4 into 5. So 4 into 5 means, so what is the size occupied by each element here? 4 bytes into the subscript variable here. So I want to know the subscript value, that is in the position 5. So into 5. So 4 into 5 is 20. So 1020. Okay, so this is the address location of the element A of 5. Okay, so this formula is very important. So next we will see about the multi-dimensional array. So multi-dimensional array is also called as array of arrays. So basically in the case of the Java, there is no concept of multi-dimensional array. There is only 2-dimensional array. So 3-dimension, 4-dimension is not possible in the case of Java. So in that case, they will call the multi-dimensional arrays as arrays of arrays. So when programming languages use 2 subscripts, they are known as the 2-dimensional arrays. Similarly, if you are going to use 3 subscripts, then it is called as 3-dimensional array. So here the declaration of the 2-dimensional array will be in this format. That is data type. So it may be integer, character, float, and array name followed by the array name, and then row size and column size. Okay. So here the 2-dimensional array will be stored in the format of matrix. In the matrix format, the elements will be stored. So in the case of the 1-dimensional array, elements will be stored in a sequential manner, right? So but here it will be stored in the matrix format. The graphical format will be in the format of matrix format. So the 2-dimensional array is again divided to two types, that is the row measure order and column measure order. So first we will see the row measure order. So A of I, J. So here the I represents the rows and J represents the columns, equals to B plus I into N plus J into W. So here B is the base address, and I indicates the subscript variable, that means which memory location we are going to access, right? That is the row and column. J means column. So the subscript variable representing the row and subscript variable representing the column here. So B plus I into N plus J into W if the index start with the 0. So this formula will follow for the array which is starting with the index 0. Suppose in some programming language it may not support, so it will start the index with the 1, like A of 1, 1, like that. Okay, so in that case this formula will be like this. So here simply we are going to subtract one value from the given formula. Okay, that is I minus 1 and J minus 1 we are taking. So B, that is the base address plus I minus 1. So from the row subscript we are subtracting 1, and from the column subscript we are subtracting 1, right, into N plus J minus 1 into W. So whole W. So here M represents number of rows, N represents number of columns, D is the base address, and W is the word size, which is in bytes, right? So we will see an example to know clearly about the row measure order. So here the given example, the elements are stored in the format of matrix, right? So that is so here we are taking the row with the 3 rows and 4 columns. Okay, so this is a 3 by 4 matrix. So for 3 rows and 4 columns we are taking a 3 by 4 matrix, and we are storing the elements in the 3 by 4 matrix format. So the memory representation will be in this format, right? So this is the graphical representation of the row measure order, but in the memory it will be stored in this given format. Okay, so 10 represents the 0 0 location, 20 represents the 0 1, and 30 means 0 2. That means in the 0th row and second column it is read, right? That is 0 2, and the 40 represents 0 3. So this is the particular subscript of the element. Okay, so this is only the graphical format of how we are storing the elements in two-dimensional array. But if you come to the normal actual format, how the data will be stored in the memory means in this format it will be stored in the case of only row measure order. Okay, so that means we are considering the values row wise. Okay, so A00, A01, 02, 03. Again the next one is 10, 11, 12, 13, right? And then A20, 21, 22, 23. So in this given manner only we are going to consider the values 10, 20, 30, 40 and 50, 60, 70, 80, 90 to 300. Okay, so in this format we are going to the data will be inserted into the memory, and since we are using the integer numbers it will occupy 4 bytes of memory. Okay, so now let us see how to solve this using the formula. Okay, so since we are using the values starting with the subscript 0, so we are considering this basic formula, that is B plus I into N plus J into W. Okay, so I want to know about the subscript variable in the ith row and jth column. Okay, so here I am taking the 1 2. So I want to know the address of the element in the first row and second column. Okay, so for this I am taking the base address, that is 1000 plus I value is 1 and j value is 2. So 1 into 4, so n represents the number of columns, so 1 into 4 plus 2 into 4, that is the number of bytes occupied by the element. So if you calculate this, it will give the result 1024. Okay, so A12 is stored in the 1024 memory location. Okay, so this is the row measure order. So next we will see the column measure order. So in the column measure order also we are having the same formula. If the index is starting with 0, we will be having the base address plus j into m plus I into word size. If suppose the index is starting with 1, then b plus j minus 1 into m plus I minus 1 into w. That means simply we are subtracting one value from the j and I subscript here, right? So now we will see the example here. The same example I am considering, but in the column measure order we are going to store the elements in the column wise. Okay, so this is the graphical part of the values, and how we are going to store these values in the memory means we are going to store the values in the memory in the column wise. In the row measure order we have stored the elements in the row wise in the memory. So similarly here we are going to store it column wise in the memory. That means like this. So A00, A10 and A20. Okay. Next, so we will go to the next column, that is A01, 11 and A21. Right. So next A02, 12 and 22. And then A03, 13 and 23. So in this manner we are going to store the data into the memory. Okay. Suppose here I want to calculate the address of the particular location, that is 01. I want to calculate the address of the value stored in the location 01. So then how to calculate means A of 01, that is equals to 1000 is the base address and j is the subscript value, that is 1 into m is the number of rows, that is 3 plus 0 into 4, that is the word size. So if you calculate this, you will get the answer 1012. That means 01 is stored in the 1012 memory location. So this is about the how to calculate the row measure order and column measure order for the two-dimensional arrays. So if you want to consider some real-time example of the two-dimensional arrays, you can consider the tray of eggs, right? So in the egg tray, so in the case of the egg tray, so it represents the two-dimensional array. That means in the particular tray we will be having the rows and columns. So in this tray, so we are having 2 rows and 2 columns, right? So if you want to store the eggs, we are going to store the eggs in this particular spaces, right? So similarly, this is some real-time example of the two-dimensional arrays. Okay. So in the two-dimensional arrays, elements will be stored in the matrix format. So now let us go to the next one, that is a 3D array. So in the three-dimensional arrays, we are having the rows and columns, and again in the columns we are going to store some values here. So in the first row we are having three rows, 3 columns, and in each location we are having 2 elements stored, right? So we are having the 3 rows here, right? 3 rows and 3 columns, right? 3 columns here. And then in each location we are storing 2 values, that is 1, 2, 2, 4 and 5, 7, right? So this is the graphical representation of how we will store the elements, but in the actual format it will be stored in the linear format in the memory locations, like 1, 2, 2, 4, 5, 7 and then 9, 2, 3, 4, 5, 4. So in the linear format it will be stored in the memory location. So next we will see an example of how to solve the 3D arrays. So int a of 10, 20 and 30, that is with 10 rows, 20 columns, and in each position it will be storing 30 elements. Okay, in each location we will store 30 elements. So here the base address is starting from 5000 and W represents the word size. Okay. So in the row measure order, so here also we are going to represent the 3D array in 2 types of orders, that is row measure order and column measure order. So in the row measure order, the elements will be stored in the memory in row wise, whereas in column measure order, the elements will be stored in memory in column wise. Okay. So here 7 rows, 6 columns and 5 values. So in each location 5 values will be stored. Here we want to find out the 3D array. So in the row measure order, the elements will be stored in the memory in row wise, whereas in column measure order, the elements will be stored in memory in column wise. Okay. So here 7 rows, 6 columns and 5 values. So in each location 5 values will be stored. So in each location 5 values will be stored. address location, the address location of this particular subscript value. Okay, 7 rows, 6 columns, and 5 fixed values. Okay, so for this we have to consider the 5000, that is the base memory location, plus, so we are neglecting the row here because, so this is the row measure order where we are neglecting the number of rows. So except this, so 7 into 20 plus, so 7 into 20 into 30 into 4, right? 7 into 20 into 30 into 4. 4 is the word size, plus 6 into 30 into 4 plus 5 into 4. So this is how we will be writing the address. We will be writing how to calculate the address of the particular location. Similarly, for the column measure order, so we are neglecting the column here. Okay, so for this 5000 plus 7, so we are starting in the reverse format for the column measure order, starting from here. So 7, 6 and 5 we will take. So 7 into 20 into 10 into 4. So in the reverse format we are going to take the values here in the column measure order. 7 into 20 into 10 into 4 plus 6 into 10 into 4 plus 7 into 4. Sorry. So here in the column measure order we are going to consider it in the reverse format, right? So starting from the 7 we are going to consider. So here also in the reverse format we will apply the formula. So first we will take 5 into 30, 7 into 30 into 20 into 4 7 into 20 into 10 into 4. So for the row measure order we have left the first element, right? Here we have left the first element and we started from the second element. Similarly here in the column measure order we are starting from the, in the reverse format we are neglecting the first element and starting from the second element, that is 7 into 20 into 10 into 4 plus 6 into 10 into 4. Okay, next plus 5. So here also we are taking reverse, right? So 5 into 4. So in this manner we are going to calculate the, so if you calculate this we will get the particular address location of the value. So in this manner we will know the 3D array both in row measure and column measure order. So instead of learning the formula, this is the best method to calculate the array location. For the 3D arrays, the real-time example is apartments. So in a particular apartment, right? So in a particular apartment there will be 4 floors. Okay, and in each floor there are 2 flats. Okay, so in this manner we can consider for the 3D array, right? So for the 3D array, so here there are 4 floors and in each floor there are 2 flats. Okay, so like this you can consider the 3D array. Okay, suppose you can consider this as the 10 as the number of floors and 20 as the number of flats. 20 as the number of flats and 30 as the number of people living in the flat, right? So here we can consider the, suppose I am taking the value 5, 3 and 4. So this is a 3-dimensional array A of 5, 3, 4. That means, so in the particular apartment there are 5 rows and in each row there is 3 flats here. In each row there are 3 flats and in each flat, that means in each flat 4 people are living, right? So in this manner we can understand the 3D array. So in the 3D array, in the previous this one also, if you consider in each row So here we are having 3 rows and 3 columns, and in each position, in each location we are having 2 elements. Similarly here in an apartment, so in apartment we are having 5 floors, right? In each floor we are having 3 flats, and in each flat we are having the 4 people living. Okay, so this is a best example of the 3D array, for the real time example of 3D array. Thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.